Hello and welcome to another special bonus episode of Damn Interesting Week. This bonus episode is about everyone's favorite red planet, or God of War, or the first movement of Gustav Holst's timeless orchestral suite, The Planets. Strictly speaking, it should actually be the third movement because he did all the other planets in order, but for some reason he decided to swap Mars and Mercury. It is annoying. But maybe he did it because he thought Mars was so cool, and we can't argue with him there. So we've put together a collection of some of our favorite articles from the archives on the subject of Mars, and, feel free to skip around and listen to them out of order in honor of Gustav Holst. My name is Jennifer Lee Noonan.
I'm Angela Epley.
I'm Spurr-Chen.
I'm Bradley Calhoun.
And these were some damn interesting weeks.
First Link.
Well, we've talked a lot on this podcast about how to live on Mars, but what we haven't talked a whole lot about is how to die on Mars. And this article from astronomy.com is not looking so much at ways to die, but rather what happens when a human inevitably does die on the red planet. Because, the reality is shipping your body back to Earth, it's a nice sentimental choice, but it's probably not going to happen.
No.
Even once we've got a working outpost, it's still going to be very expensive to make the trip. But on the flip side, the least sentimental option of recycling the organic material into useful stuff or even, food for the funeral party is probably too much for even the most cold-hearted scientist to accept. So, realistically, the author here suspects that we're going to settle on the middle ground of Martian cemeteries. Yeah. But the issue with that, and there are many, is that decomposition won't work the same way on Mars as it does on Earth. So, when a body dies on Earth, there are several phases. First, the body cools, which is known as algor mortis. Then the blood begins to pool downward due to gravity, also known as livor mortis. Then we get to the more familiar state, rigor mortis, which is when the muscles start to stiffen. But the stiffness only lasts for a short time because enzymes in the body start to break down our cells in a process called autolysis. Meanwhile, the bacteria in our gut that digest our food just keep right on trucking and begin to digest us from the inside out. And I didn't know that. That's actually what's happening when a body is starting to rot. It's not usually bacterial infections from the outside. It's our own bacteria trying desperately to stay alive.
Wow.
And then finally, of course, the circle of life becomes complete as scavenger species such as insects and carrion birds and even some species of fungi discover the tasty meal that we've left behind and start to work inward. So Nicholas Pasalacqua, the forensic anthropology director at Western Carolina University, notes that these are species that have evolved alongside other forms of life on Earth. And while it may seem like an obvious statement, it's actually a big deal that as there is no life on Mars, there are no creatures that fill that scavenger niche either. So what happens when there are no bacteria or fungi or anything else to break down dead matter? Pasalacqua says we can actually look to similar environments on Earth, namely places where it is so cold that none of these species can survive. Of course, Mars itself is also very cold, with temperatures ranging from a balmy 24 degrees Fahrenheit during the warmest part of the day all the way down to negative 140 degrees Fahrenheit at night. So assuming that we bury these bodies in Martian soil or, just chuck them outside the habitat, we can expect that they will freeze. But since Mars is so dry, we can also expect that moisture will evaporate quickly from the corpses through sublimation and basically turn them very quickly into desiccated mummies. What's more, the bacteria in our gut are largely aerobic, meaning they need oxygen to live, so they would actually die off very quickly once we're placed outside, and the few anaerobic species we do have inside us would only last a little bit longer before freezing to death. Freezing will also halt the enzymes responsible for autolysis, and so what we're looking at is extremely well-preserved corpses that simply will not go away over time. And aside from the waste of resources, that's actually a problem long-term, because the thing is, on Earth, we actually reuse cemetery plots quite a bit once the bodies in them have fully decomposed. We don't necessarily think about it, but if every person who ever lived and died on Earth was still right where we left them, there'd be bodies everywhere.
Yup.
Yeah.
So, Pasalacqua says, like it or not, we are probably looking at the recycling option, even though most people won't want to think about it.
I'm fine. I would prefer to think about it because at least that provides materials that are going to be really difficult to obtain or ship or discover on a planet that has no reason to support this kind of life.
Mm-hmm.
Yeah. I mean, I think as the person who is dying, you're okay with it. But if you're the person who's still alive and like you lost your beloved father and now you're eating dinner going like, he's in here. Like, there's definitely parts of him in this. I don't know. I think it's the people who are still alive who are most disturbed by it.
Well, that's true of every hang-up we have about death. So.
Right, that's true.
Yeah. We had proposed a solution for this in the past, which seemed inappropriate for Earth, but might be the ticket for Mars, which is to shoot the corpses into space.
That's true. But then also, I mean, I guess they'd probably burn up, but there's no atmosphere to burn them up. So, like, would you end up, because this happened on, God, what was it, Avenue 5? It was a show with Hugh Laurie about a luxury space liner, and like they shot a body out into space, not realizing that it was just going to orbit the ship. And so like there's just this dead body constantly orbiting the ship throughout the show. It's very funny. It's done very well. But
wow, I've never even heard that show. I want to check that out.
Oh,
now.
it's
I
so
mean,
good.
yeah, because what I'm imagining now is essentially like a hearse ship, you know?
Right.
Like you just have a ship that is set course for the sun or something like that. I don't know.
Yeah, or maybe you've just got your regular transport ships, stack a couple of corpses in there, and then they have just shoot them out the airlock while they're in space.
Yeah.
Far enough away that they're not going to go into orbit.
Yeah.
Then you resume your normal transport
But,
duties.
put them in a cape and give them a cool name like the human torpedo so that it can then become this, installation, if you will.
I guarantee you some Martian version of Banksy is going to be like, I've gone and put all these corpses up there, reckon with it, Like...
Look at us, just a bunch of PhDs in here.
Exactly. There is, for what it's worth, one other possibility, which won't be available right away, but could develop over time. And that is the evolution of new scavenger species that are adapted to the Martian environment. Because that's what evolution does, right? If there's a hole in the food web that needs to be filled, something's going to eventually fill it. So if we did have ourselves a little Martian cemetery right outside the habitat, especially if we keep it just a little warmer than the surrounding wasteland, it's possible, they say, that the anaerobic bacteria we brought in with us could adapt surprisingly rapidly, and that could actually speed up our terraforming efforts in the long run by creating this rich soil full of organic matter, which is what we have on Earth, even though we don't like to think about it, but our dead people on Earth are recycled into our food. It's just a much slower natural process.
Yeah.
But I don't know, I have to admit, the word cemetery kept popping up so much in this article, I kept thinking of Pet Cemetery. And I was like, what if we get to Mars and we find out, like, you bury something in the Martian soil and it comes back? Like Martian zombies?
Or even just sort of this, conjecture of maybe the bacteria can evolve. Well, yeah, but in what direction? Maybe it'll evolve to replicate what we have on Earth, which is what it sounds like they're hoping. But maybe we could create some kind of super Martian bacteria that's like, and now we have zombies.
That's right. And then if we get the zombies, the way we deal with them is to shoot them into space. And so now you have living-ish zombies rotating around the planet. It's like an armor barrier. Like it protects you from people.
It's that old Coke commercial of, if I could give the world a Coke and we'll all hold hands, except it's really more like zombie planetary defense.
Exactly.
I'm down.
Exactly. Next link?
Next link.
All right, good news, everyone. According to phys.org, after 6 months on Mars, NASA's tiny copter is still flying high. Go tiny copter.
Nice.
Good? That seems
Good
like
work.
that's a long time for it, I guess?
Yes. It was only supposed to fly 5 times, but NASA's Ingenuity helicopter, it's completed 12 flights, and it's not done yet. It's not ready to retire. So Josh Ravich, the head of Ingenuity's mechanical engineering team, was positively glowing in this quote. Everything is working so well. We're doing better on the surface than we expected, which is also fun to read if you can imagine a really frazzled mechanical engineering head who's absolutely perplexed as to why everything is working so well, right? You could also read
he's
it
just
like,
giddy, like, oh my God, you guys.
It could be happy or it could be deeply suspicious too. Like everything is working so well.
Right.
But I mean, hundreds of people did contribute to this project, so maybe it's not a surprise after all. Only about a dozen currently retain day-to-day roles. And part of the reason they're so shocked at how long this has lasted is because the air on Mars has a density equivalent to only 1% that of Earth's atmosphere. So to compare this, like flying a helicopter on Mars would be like flying one in the thin air nearly 20 miles above Earth. And it wasn't easy getting to Mars in the first place. Ingenuity had to withstand the initial shock of takeoff from Earth, and then of the February 18th landing on the Red Planet, following a 7-month voyage through space strapped to the rover's belly. Talk about a stowaway.
Wow.
And then once it was on Mars, the 4-pound copter has had to survive the glacial cold of Martian nights, and it's been drawing warmth from the solar panels that charge its batteries during the day. Its flights are guided using an array of sensors, since the 15-minute lag in communications from Earth makes real-time guidance impossible. It had its maiden flight on April 19th, made history, and it has gone on to fly 11 more times. Quote, by Flight 3, we had actually accomplished all of our engineering goals and got all the information we had hoped to get. All put together, it's covered a distance of 1.6 miles, which is quite mighty for a helicopter we're operating from here on another planet.
Right.
So right now it's being sent out to scout the way for Perseverance using its high-resolution color camera. But they're doing this to chart a new path for the rover that is safe, but also that hopefully has some scientific interest, specifically with respect to like geological terms.
You ever think that they maybe like really downplay the expectations? Where they they honestly thought it was going to fly about 20 times, but they're like, no, say 5.
Yeah.
And then
Listen, the best project managers know
Yeah.
you
under promise and over deliver.
Yeah. Next link.
Next link.
Well, I swear to you, this is not planned, but we're going to stick in the digestive tract for a little bit.
Yay!
Sort of. I'm maybe stretching the segue a little bit. But I have to say, whoever came up with the title of this next article is really patting themselves on the back. And I think they deserve it. This comes from Tim Lewis at The Guardian. The headline is, Gardens of the Galaxy. Can you grow vegetables on Mars? So it's an exploration of 2 different scientists working on kind of different angles of this problem. The first one is Dr. Wieger Wammelink. He's a senior ecologist at the Wageningen University in the Netherlands. And he has been studying the subject since 2013, but he actually has said that most institutions, including NASA, have brushed him off and refused to give him grants, saying, well,
Rude.
this is a dumb problem, we're just going to bring the food. Like, of course you can't grow things on Mars, quit it. But he said the release of the movie The Martian in 2015, where he grew a whole bunch of potatoes, has significantly spurred interest. And now he's like, it's super easy for me to get grants and study this. And he feels like...
Good for him.
Yeah, he's like, well, if this is what it takes, then great. So he grows his plants on Earth in what's called a regolith simulant, which is a NASA-approved substance that mimics the soil found on different planets. So, for example, moon soil comes from a desert in Arizona, and Mars soil comes from the side of a volcano in Hawaii, which is then sort of cleaned and rolled to make it a little drier and dustier. And normally these are used for things like, can the little wheeled vehicles drive over this? Or what's going to, what are the physical properties of this dirt? Apparently, no one has ever tried to actually grow anything in these simulants, which is very strange. But this guy has, fortunately. His very first plant was a success. He tried to grow garden cress, which is also known as upland cress, which I had to look up. Apparently, it's related to watercress, but it's not. It's a lettuce, basically. And crucially, when it grew, it did not uptake the many toxic metals that are in the fake Mars dirt, right? It's not pulling up the lead and the mercury and stuff. So you could, in theory, eat it without getting poisoned. And he said in subsequent generations, adding sort of the leaves and the roots from his harvest as a fertilizer, along with some earthworms, subsequent harvests have been much bigger and healthier. And he's like, this is a very viable thing that we could be doing. So far, he has now successfully grown tomatoes, peas, radishes, carrots, and potatoes. Everybody's favorite.
Wait a minute. So the soil properties and experimenting with that, even though they're kind of artificially reconstructed here on Earth, that seems to be viable. But what about the atmosphere? I mean, there's no...
Right. there is an issue.
Need to have right.
Yes. I mean, presumably, if we're going up there, we've figured out the atmosphere problem to a certain degree. We've got our astronaut gardeners to grow them. So this is sort of long-term thinking on his part of like, okay, if we're going to set up a moon base or a Mars base, we will need long-term food. You can bring up 2 to 3 weeks of food, but even the trip to Mars alone is 6 months.
But it's definitely predicated by having a human-appropriate type of atmosphere that also the plants are clearly dependent on.
Well, and so that's kind of what the second scientist they feature is Dr. Gioia Massa, who is working with NASA's Vegetable Production System, aka VEGGIE. And she basically said, yeah, obviously this is going to need atmosphere, this is going to need a lot of tending, at which point the use of the dirt is kind of an unnecessary aspect of it. So their system is not using planet dirt at all. It's just experimenting with what they called modified hydroponics, using not true just water-based, but a porous clay substrate that has all these holes in it that holds the water nearby around the roots. And actually, these are currently growing on the ISS. They have 3 types of lettuce, some Chinese cabbage, red Russian kale, Mizuna mustard, and apparently zinnia flowers. And I don't think those are of any use except they're pretty. And they wanted to just see could they grow flowers.
Yeah.
And those they have demonstrated. The astronauts are actually allowed to eat some before they send them back for further studies. And they said, yeah, they're just as nutritionally complete as any lettuces grown on Earth.
Huh.
So on the one hand, Massa's veggie program takes more work because the astronauts have to constantly monitor and sort of judge the correct amount of water. And she said they are frequently getting it wrong. Like, this is a learning process for them.
It's gardening.
Right. But it is guaranteed safe, unlike Mars dirt. She notes, possibly a little snarkily, that Martian soil does contain perchlorates, which the simulant dirt does not. And perchlorates are highly poisonous, and they're not at all included in Wamalink's study. So who knows, possibly growing stuff in actual Martian dirt would be totally poisonous and not possible. But both of them agree that multiple strands of investigation are good. There's no ideas that are too outlandish to rule out. Wamalink is also working on the idea of possibly getting pollinators into space. He says bees could hibernate for the 6-month trip. And, you know, in theory, you've got your dome and they can fly around. He's also looking at using concentrated urine as a fertilizer.
Yeah, just like the Martian.
Exactly. He said in order to get enough material to test, he actually collaborated with some festival organizers in the Netherlands. He was careful to note that they tested the urine before concentrating and trying to experiment with it to make sure that it wasn't full of THC and booze.
Right. I love how the conceit of this is all kind of dependent on human tending. Like, if we are actually going to Mars and doing any kind of settlement, wouldn't we just have robots to, like, monitor the actual water levels, things like that? Like, why would a human being have to tend to this unless they really wanted to?
You would hope so. I mean, they're definitely kind of going full steam, I think, not just because The Martian came out, but because people are really sort of coming to the conclusion that, yeah, we are going to send a mission to Mars soon. And we're going to be setting up possibly a lunar base on the moon. And people are sort of seeing this as not some distant sci-fi thing, but a real thing that we actually need to start studying for and figure out what do we know about living up there. So it's very cool. They said the article talked about a couple of other experiments done in the past with sustainable food production in general. They said in 1979, Soviet cosmonauts aboard the Soyuz 32 took fertilized quail eggs, hoping that they would hatch. They didn't. In 1990, they finally succeeded. But they then found that after the chicks had been born, they struggled with feeding in 0G, and they had to wear tiny feed bag harnesses, like little itty-bitty bags on baby quail chicks' faces to feed them. And there's also some live fish up in the ISS, and they're looking at a lot of different aspects of food, not just plants, but animal as well. So I'm hopeful. I think probably we're definitely going to have to figure out sustainable food production up there at some point, because you just cannot keep supplying things every couple of weeks. You're going to have to figure out how to be sustainable. So, if we're all eating watercress and chicken eggs, I guess that's all right. It's not too unhealthy.
And who knows what the next, future generation of space bees could mutate into. That sounds absolutely terrifying.
I'm on board with the space bees. I like them. Next link.
Next link. From the BBC, this whopper of a lead. Pig vomit toxin, key to Martian meteorite mystery. And believe it or not, this has the tag on the article from the BBC of Black History Month. You ready to dig in?
What? Okay. All right.
Okay. Let's take a little step back here. So we're talking about something called the Lafayette meteorite. It was found in the drawer of an American university's biology department in 1929, but nobody at the Purdue University in Indiana could remember where it came from. There was, however, a bit of a theory suggesting that it was donated to them by a, quote, black student who witnessed it land in a pond while he was fishing. That's like the only provenance origin story they have about this meteorite. Well, over at the University of Glasgow, Dr. Aine O'Brien, an environmental and planetary organic geochemist, began her detective work 2 years ago, and it has now shed some light on who the black student might have been and when it was handed in. The reason the Lafayette meteorite is pretty rare is because it's a meteorite from Mars. And based on the way that it looks, it must have been picked up pretty soon after it dropped from the sky because otherwise the outer edge would have weathered away. So it's relatively intact on this meteorite. Most of it these days is kept at the National Museum of Natural History, the Smithsonian Institution. So they gave her like a little chunk of it. She crushed it up and used sophisticated mass spectrometry to find out what it was made out of. And the point of this, the whole reason why she was doing it in the first place, was to look for preserved organic molecules or evidence which could help her learn more about the possibility of life on Mars. And so they analyzed this little chunk of ground up meteorite, and they had a long list of hundreds of different chemical compounds. And because, by the time the data came in, it was late March 2020, and by her own admission, quote, I had nothing better to do than just scroll through the list. So a lot of them had really long, boring chemistry data type names, but one was called a vomitoxin, which, quote, I thought sounded cool, so I started looking into it. And she discovered that the vomitoxin, and I'm going to butcher the name, but it's something like deoxynivalenol, DON, it was found in a fungus which contaminates grain crops like corn, wheat, and oats. So they turned to researchers at the university's botany and plant pathology departments to learn more about the historic prevalence of the fungus in Tippecanoe County in Indiana, which is where Purdue is located. So they went through these historical records. They showed that this fungus caused a marked drop in crop yield in 1919, then another less pronounced drop in 1927, and the team suggested that dust from affected crops may have carried this DON chemical to surrounding waterways, and Lafayette may have been contaminated with it if it just fell in a pond. And they did have some fireball sightings that were reported in 1919 and one in 1927. So archivists at Purdue then went through the yearbooks to find black students enrolled at the time. Because reasons, there were vanishingly few of them, which actually narrowed down who it might be, right? So they found 3 students, Julius Lee Morgan, Clinton Edward Shaw, and Hermans Edwin Fauntleroy, and they were enrolled in Purdue during 1919. And they also found a 4th student named Clyde Silence, who had studied there in 1927. The years matched up. So they think one of these students may have found Lafayette, like the previous origin story suggested.
Yeah, I mean, it's like you're doing murder forensics on this thing, except you're just finding what really cool student was into geology. Like, it's awesome.
Next link.
Next link.
All right, this next article is from NPR, and it's called What a Decade of Curiosity Has Taught Us About Life on Mars. And I doubt anyone missed the pun, but they are talking about the Curiosity rover, which launched in 2012 and just passed its 10th birthday on the surface of the red planet. Curiosity was the 4th robot that we successfully landed on Mars, and it is, though I always forget this, about the size of a car. Like, I don't know about you guys, but there's something about the perspective of the camera angles or maybe the texture of the materials in the photographs.
Yeah, it seems small.
Yeah, I always have the sense that these rovers are like the size of maybe a dog, but they're not. They're actually really big, like drivable vehicles, assuming we ever get a person up there to drive one. But so the question this author is asking basically is, how'd we do? Was the mission a success? And according to Dr. Ashwin Vasavada, the head scientist of the Curiosity team, the answer is a resounding yes. Now, his job is on the line. Of course he's going to say yes, but he does make a good argument. He said that while Curiosity was capable of detecting actual life, which it clearly has not done, or we would have heard about it, its main goal was to find out if life was or ever had been possible on the planet, and thanks to Curiosity's data, that has now been definitively confirmed. He said it was not only habitable at one moment in time in Mars's history, but probably habitable for millions or tens of millions of years. You can see evidence that rivers once coursed along the surface, that maybe even an ocean existed at one point. Early Mars, 3 or 4 billion years ago, was a much more Earth-like place than Mars is today.
Bold words.
Yeah, that's a big statement.
Now, Vasavada believes that even though we haven't really done a ton of excavation, we've nonetheless explored Mars enough at this point to be confident that there are no fossilized dinosaur equivalents or anything like that. So if life ever did take hold, it probably never got beyond the microbial stage. And I assume these guys know what they're talking about. I'm not giving up hope for fossils. Like, fossils look like rocks. How do you know? That's like we dropped a dune buggy in the Utah desert, drove around a couple of square miles and said there's definitely no fossils in China. Like, you don't know that. I don't know. But I'm an optimist, I guess. But as for why Mars took a sharp turn into the desert planet it is today, scientists believe that it was due to the planet's smaller size, which caused it to cool faster than Earth did when it went through the same developmental stage. Once Mars had cooled, it lost its ability to generate a magnetic field, and that led to the atmosphere being stripped away by radiation in space. This led to further cooling and ultimately the conditions we see today. But even though it looks like this uniform, dusty, frankly informationless wasteland, Vasavada says the evidence that Curiosity needed was everywhere, including within the exact crater where it landed. And obviously, these NASA guys are smart. They chose their spot on purpose. But it turns out that the Gale crater, where Curiosity landed, was formed by an asteroid impact that happened either during or before this wet period in Mars's history, because it became a lake with sediments and mud deposited in very recognizable ways, both at the bottom of the crater as well as up the sides. Vasavada said, "We've now driven up over 2,000 vertical feet on the mountain," meaning up the side of the crater, "and for the most part, every layer we've looked at formed in a wet environment and had conditions that would have been favorable to life." So it wasn't just a lake, it was a deep lake, fed by rivers and basically looking exactly like you would hope a habitable planet would look. Which is all very exciting, but also sort of sad, because then you remember that we're talking about 3 to 4 billion years ago. Like, we completely missed that window. And at the same time, there's evidence that Venus also was covered in water in that same time frame. Like, Venus, Earth, and Mars were all right there at that tipping point with liquid water and maybe the first signs of microbial life, but only Earth made it out. And it makes you think, on the one hand, like, how many other planets out there in the galaxy almost got there but didn't? And also, how close was Earth to collapsing right alongside them? Like, I try not to get too existential before lunchtime on any given day, but these large-scale planetary history ones kind of get to me, especially the idea that we missed the window. Like, I think the worst thing in the world would be to find evidence of a massive alien civilization that died out 1 million years ago, and we missed it.
Well, we could also look at what happened and try not to exactly replicate it in terms of us totally using up our own resources and doing things like, man, we don't have an atmosphere anymore.
Yeah, I think probably we're going to be the cautionary tale. Someone's going to find us 1 million years later.
Exactly.
Next link.
Next link.
Well, let's keep with this theme a little bit. What if instead of a pillar of salt, you could convert your own human juice into ultra-hard concrete by mixing blood with Mars soil?
Well, okay.
Excuse me? Are they going to take us to Mars and sacrifice us to build stuff?
I mean, I will read that science fiction novella whenever you finish it, Way, but the science behind it, according to Slash Gear, is that a study has found that if you mix blood with soil found on Mars, you can make concrete that is nearly twice as strong as what we're used to concrete being, which to my recollection is pretty dang strong.
Yeah, concrete's not exactly weak.
Part of the reason they were looking into this is because it is prohibitively expensive to send building materials from Earth to Mars, which is why any future habitats would need to be constructed primarily using materials already found on the red planet. So the University of Manchester did some research and found that compounds from urine and blood may play a key role in the construction process.
Now, I feel like they're burying the lead there, because they're all like, oh, we could take your blood or your urine, but really we want the blood. Like, I have much different feelings about donating those two different substances. You know what I mean?
Oh, yeah. I mean, the way that this is all laid out, it sounds like a cult, right?
Right.
But this is just a chemical thing. So they've decided to call this material astrocrete, which I'm kind of surprised they didn't go with astrosecrete. But, you got to pick your battles, and naming is one of them. But of the materials created, the best performing sample had a compressive strength of 40 megapascals, which is higher than ordinary concrete's 20 to 32 megapascals. So they did some quick math, and a 6-person crew on Mars could contribute the biological materials needed to produce around 1,100 pounds of astrocrete in around 2 years. They also note the amount of the Martian concrete produced would expand with each new crew member added to a long-term mission, producing greater amounts of concrete for building expansions. You getting some Hale-Bop vibes yet on this one?
Yeah, the more astronauts you put on the ship, the more urine you're going to get. That's not shocking. But it does sound a little bit like, we've got our crew of people who are really only here for the blood and the urine. Like, we've told them they're really smart and they're good enough to be astronauts, but we all know what they're really for. Like, honestly, you know how we're always like, oh, Roman concrete was so much stronger than ours was, and we think maybe they used ash. Maybe they just used blood. Maybe they were doing things.
I'm delighted you brought that up, because the concrete may prove more... Well, okay, they did say that the idea of mixing blood with soil to make concrete is not new, and they don't get into things like whether it's Maya or Roman, but yeah. Anyway, next time you're building your house, think about a little bit of blood magic. You don't know if it's going to make it stronger or not, but you can only find out.
I mean, I'm not going to drain my blood for it, but I also am very clumsy and often injure myself. So, like, if the blood's there, I'm not opposed to using it necessarily.
Yeah, if you happen to be on a construction project and you're bleeding, why not?
Yeah, I'll take my blood. I don't care anymore. All right, well, that's going to wrap it up for this bonus episode. We hope you've enjoyed it. As always, Damn Interesting remains an intentionally ad-free experience both on our website and in all our podcasts. So if you agree with that philosophy and want to support us, you can do so at patreon.com/damninterestingweek. In the meantime, my name is Jennifer Lee Noonan.
I'm Angela Epley.
I'm Spurr-Chen.
I'm Bradley Calhoun.
And we hope you have a damn interesting week. Bye-bye.